Hello students, I am Dharmveer, your teacher and host, and you are watching GradeCube. This is the debut video of this channel, and hence I am going to start with a very simple topic named Arithmetic Progression. Let's have a look what we are going to do today. So our today's agenda is we are going to learn what is a sequence or a series, because before knowing an AP we will have to know a sequence or a series. Secondly, we will know what is an arithmetic progression or an AP. Then we are going to learn what is the nth term of AP or arithmetic progression. After that, we will learn the general form of arithmetic progression or an AP. And finally, we will have a look at a couple of examples. So let's get started. Before you know what is an arithmetic progression, you will have to know what is a sequence or a series. So, a sequence or a series is a list of numbers called terms in which each consecutive term is related to other term by a definite pattern. To understand that, let's have a couple of examples. In first example, we will take some simple sequence. For example, let's have a sequence 1, 4, 9, 16, 25, and so on. Now this is a sequence or a series because there is a definite pattern in it. And what is the pattern? Let's inspect. If I write this sequence in other words like 1 square, comma, 2 square, you can see 1 square is equal to 1 and 2 square is equal to 4. Similarly, 9 can be written as 3 square. 16 can be written as 4 square. Similarly, 25 can be written as 5 square. And hence we know what will be the next term. It will be 6 square because it is increasing by 1. Every term is increasing by 1, having square on each of it. So there comes the 6 square. 6 square means 36. So we know that the next term will be 36 on this sequence. That's why it is a sequence, because we can predict the next number. Okay, let's take another example. In this case, let's take a complex example. For example, say 2, 7, 22, 67. Now, can you find out the sequence? It looks somewhat difficult, but it isn't. Let me write it in other manner. Let the 2 remain as it is. I will write 7 as 2 multiplied by 3 plus 1. See, 2 multiplied by 3 is 6 plus 1, it becomes 7. Okay. Then I will write 22 as this 7 or this 7 multiplied by this 3 plus 1. Now 7 into 3 is 21 plus 1 means 22. Here is the 22. And finally, I will write this 22 multiplied by again 3 and adding 1. It becomes 66 plus 1 means 67. Here's the 67. So again it is a sequence or a series. Again we can predict the next term. What will be that? This 61 multiplied by 3 and adding 1. It comes out to be 201 plus 1 means 202. So the next term should be 202. I hope you understand what is a sequence or a series by now. But these sequences or series are not the arithmetic progression, because these are not the patterns for arithmetic progression. Arithmetic progression is a sequence or a series in which consecutive terms have equal spaces or distances between them. To understand that, let us have some examples. First of all, the simplest one, let me write some numbers. And hey, you know that these are the natural numbers. Let us check the difference between the consecutive terms. Here the difference is 1. Again the difference is 1. Again 4 and 3 difference is 1. Difference between 5 and 4 1. So each successive term is 1 more than the previous term. That's why it is an arithmetic progression. Let's check another example. Let me take 4 minus 1 minus 6 minus 11 minus 16 and so on. Let's check the difference. Difference between minus 1 and 4 will be minus 1 minus 4 means minus 5. Similarly, the difference between minus 6 and minus 1 will be minus 6 minus minus of 1, which is minus 6 plus 1, again minus 5. Here the difference is minus 11 minus minus 6 means minus 11 plus 6, again minus 1. And finally, the difference between these two terms will be minus 16 minus minus 11, which is minus 16 plus 11, again minus 5. So, because the difference is same in all the consecutive terms, that's why it is an AP. If you are wondering what are these three dots doing here, they actually represent that this series is going up to infinity, means there's no end to this series. If there are no dots in the series, then that series terminates there. For example, if I write 4, 6, 8, 10 and there are no dots, then this series has only 4 terms. Hope you understand this concept. Now we will come to the next part. Now we are going to deduce the formula for nth term of an AP. For that purpose, I am going to take a very simple arithmetic progression like 1, 3, 5, 7, 9 and so on. The first term of AP is called A1. So A1 is 1. Second term is called A2, means A2 is 3. Third term is A3, means 5. And fourth term A4 is 7. And finally A5, the fifth term, is 9. Let me write these terms in another format, which is 1 plus 0. What is this 0 will be discussed later. Then 1 plus 2. Then 1 plus 2 plus 2. If I total these numbers, it comes out to be 5. Again 1 plus 2 plus 2 plus 2. These are 2 plus 2 plus 2, 6 plus 1, 7. And finally, I am going to write 1 plus 2 plus 2 plus 2 plus 2. These are 4 times 2 means 8 plus 1 equals to 9. If I write these terms in another format, then this becomes 1 plus 0 multiplied by 2. From where this 2 came will be discussed later. Then again 1 plus 1 multiplied by 2. This is 1 plus 2 again. Now 1 plus 2 multiplied by 2, because there are two 2's. Similarly 1 plus 3 times 2. 1 plus 4 times 2. Now what is this term 1? It is common among all the terms and this is nothing but the first term. So here the role of first term is very important. It is generally taken as A and here the value of A is 1. Then comes this 2. This is nothing but the difference among these consecutive terms. This difference is called common difference. It is generally taken as D. small d, and here the common difference is 2, this 2. And finally, what are these terms doing here? If you look carefully, you will observe that each term which is present here is 1 less than the number of term which is 1 here. Similarly, there is 1 here, it is 1 less than this number which is number of term. So first of all, number of term or term number is taken as n. For example, value of n over here is 1, here the n becomes 2, here the n becomes 3, and so on. And here this is 1 less than n, means n minus 1. So any nth term can be written from here. The first term means a plus this value. This is 1 less than n, means n minus 1. And this term is common difference, means d. So this is the formula for finding out the nth term of an AP. It is an equal to a plus n minus 1 into d. Hope you understand up to this point. Now comes the general form of AP. As we have learnt, the formula for nth term is a plus n minus 1 d. So a1 becomes a plus value of n is 1 minus 1 into d, means a plus 0d. It is a. Similarly, a2 becomes a plus n minus 1, means 2 minus 1 d. It becomes a plus 1d, and 1 need not be written, so it becomes a plus d. Similarly, a3 is a, put the value of n here, plus 3 minus 1 into d. It is a plus 2d. Let me calculate one more term for you. It is a4, value of n becomes 4, a plus 4 minus 1 into d. It becomes a plus 3d, and so on. So general form of AP can be written as first term a, second term a plus d, third term a plus 2d, and fourth term a plus 3d. And I hope you understand what will be the next term. It will be a plus one more over here. It will become 4d, a plus 4d, and so on. So I hope you understand till this point. Now let's have a look at some examples. Here, example 1 is check if given sequence is an AP or not. The sequence is given here. Here A1 is 3, A2 is 7, A3 is 11, A4 is 15. To check if it is an AP, we will have to calculate the difference among two consecutive terms. For this, I am going to calculate A2 minus A1. This is 7 minus 3 equal to 4. Again, A3 minus A2, difference among these two terms will be 11, A3 11, A2 7. It is again 4. And final this difference, A4 minus A3, which is 15 minus 11, again 4. We will say that because all the differences are same, therefore it is an AP. Let's have a look at another example. Example is same. We have to check whether it is an AP or not. Here A1 is minus 1.2, A2 is minus 1.5, A3 is minus 1.8, A4 is minus 1.2, A2 minus A1 will be minus 1.5 minus this term, means we will have to keep it in brackets so that these two minus signs remain separate. It becomes minus 1.5, minus into minus plus 1.2, and the difference is 0.3 having negative sign. Similarly, A3 minus A2. A3 is minus 1.8 and we are to subtract this term, which is minus 1.5. It becomes minus 1.8, minus into minus is plus 1.5. Again the difference comes out to be minus 0.3. So we see that this looks like an AP. But we will have to calculate the next difference also, because that may be the game changer. So A4 minus A3, it is minus 1.2 minus 1.8. It becomes minus 1.2, minus into minus plus 1.8. And if we have look at this difference, it is 0.6, which is not equal to the previous differences. We will say because all the differences are not same, therefore it is not an AP. So keep in mind that you will have to check all the differences before you say something about whether it is AP or not. Now I will end this video at this point and will take some examples related to nth term of an AP in the next video. Till then, keep practicing and be safe and be happy. Thank you. Bye bye.